Hello everyone, welcome to Cyrix Digital Academy's Basics of Blockchain and Cryptocurrency course, and we are going to be focusing on introduction to blockchain technology. In this video we are going to be taking a look at what blockchain is, the types of blockchain, how the blockchain technology works. Probably while searching on the internet, you might have come across the word blockchain and cryptocurrencies, and you are like, what the hell is this? So you want to get to understand what blockchain means, what cryptocurrency means, what they are, and all the things you are seeing online are using quite difficult terms that are really difficult for you to comprehend. Well, in these videos we have made these really broken down for anyone to understand. So we are just going to get started to understanding first what blockchain is. So first of all, blockchain, let's break out those words. Contains two words, as you can see. It's a compound word that you see, block and chain. So blockchain is a system that allows recording of information such that it is difficult or impossible to change or hack the system. That's basically what blockchain means. Okay, well, basically what blockchain means in a layman understanding, and I believe you understand what it means to record an information. I believe you know what it means for something to be impossible to change or hack. It means it is impossible for you to cheat on that thing, it is impossible for you to break that thing. Okay, so that's basically what blockchain means. Okay, so blockchain allows this information to be recorded in a form of a ledger and is distributed through its network, but not editable or not edited. Okay, what that basically means is this information that is being recorded on the blockchain is recorded in form of a ledger. Okay, I believe we all do transactions with our mobile bank app or whatever we do. Sometimes we see the ways transactions are recorded. The transaction you did, you see your bank statement, you see the one you did the previous day, the one you did today, the one you did um let's say a couple of months back. It's all recorded in form of a way like a ledger. Okay, so that's basically what blockchain does. Okay, and what a blockchain adds to this is that it is distributed, unlike the fact that in the case of your bank is the only one holding this data. They are the ones that generate it and send it to you. In this case, you are the one that records this information for your own information. If you are recording your own data, you make a record of this and send it to the network, because blockchain uses a network to you know to accept things that come into it, unlike in your banking system, or that in that case they are the ones that are central. They are the ones that give control over every data or information that comes on it. Okay, so in the case of blockchain, the users of the blockchain are responsible for recording information. That's basically what it means. So it means that anything that comes on it, you and I are responsible for putting it there. Okay, it's nobody, no central person is responsible for that. So blockchain is a specific type of database. It's basically just a database, just like you have your Google Drive, or your Dropbox, where you basically just upload your data. When you upload your data on any of those things, you want to back it up, you send it and the thing goes to their server. Let's say in the case of Google, it goes to Google server, and when that goes there, they convert it to a format where they can store it in their own database and store it there for you. Okay, that's basically what blockchain is, the kind of database that ensures a similar thing. It differs from typical database in a way that it stores information, because blockchain stores its data in blocks. Okay, it doesn't just store all the information in a kind of one big book or place like that. It divides this information, this data that comes in, it divides this data into blocks. Okay, and these blocks are then chained together. Okay, so which makes it impossible for you to go and change one and then make changes. We'll come into that to see how that is why it is impossible to change. As new data comes into a fresh block, once the block is filled with data, once information is filled on a particular block, Remember, we're talking about block and chain, so it's about blocks coming in to chain together, okay, to come together, okay. So once a particular block is filled with data, it is then added to the previous blocks that have been existing, which now makes it a chain of blocks, okay. So these data are chained in a chronological order. They are chained in a very orderly manner. So you don't have a situation where you see a block was mined today and the one of yesterday, you see the one of today going before the one of yesterday. No, it's not possible. I'm going to come into some new terms I mentioned there, which is mined or something. We are going to get into that, and I believe as you're watching this video, you are going to also take out the time to watch the whole of the playlist in this video, so you get to understand the full concept of blockchain and cryptocurrencies. Okay, so there are different types of information that can be stored on the blockchain, but the most common use so far is as a ledger of transaction. Okay, the blockchain mostly used to store transaction. Basically, they can be used in other sectors. They can be used in health, in every other place. They can be used to store. The thing is, it just stores data. Okay, but the most use it is used for now in our time is for transactions. Okay, you can see an example of a blockchain like the Bitcoin blockchain, and a Bitcoin. The Bitcoin, actually, you might be asking, what is Bitcoin? Bitcoin is a cryptocurrency, okay, that has its own blockchain, which is known as the Bitcoin blockchain, which allows what facilitation of recording of transactions, okay, in these formats we have been explaining so far, okay. And it doesn't belong to any single person. Of course, the Bitcoin blockchain doesn't belong to any single person, okay. It belongs to a network of persons. As I said earlier, the blockchain ensures that it's not just one person that sends in data. It's collective users. Me and you, we are responsible for putting in data on the blockchain. So it is decentralized and immutable, which means that data entered is irreversible. When you go to the blockchain and send in any of it, you can't go in there and say, I made this transaction, I want to go and delete it because I don't want my mom to see it, I don't want my dad to see it, I don't want my friends to see it or something. You can't do that because the blockchain is decentralized, and things that are written in there are immutable, which means they are irreversible, okay. So any transaction, anything that goes in there are permanently recorded, and anybody can see it in the Bitcoin blockchain. Okay. Other blockchains, some of the data might be hidden because of the different types of blockchain there are, which we are coming into that. So now, how does the blockchain basically work? Okay. Each block on the blockchain contains three basic things. Okay. First of all, the data. What are you storing inside that blockchain? What is that you are storing? That is the data. Okay, you can see it here. So that's the first thing it stores. The next thing it stores after the data is previous hash and the hash for the next block. Okay, so what this means is that the previous block that existed is going to create a hash, which is going to be what links this one with the previous one. I don't know if you understand. Let's say I put in data into a particular box, into a particular block like this. Okay, the only way this block can link to the previous one, which is the whole essence of the blockchain, the only way is by creating hash. So after this block is being completed, it creates a hash for itself, okay, which you will now use to link it to another block, okay, which you can now see here. Hash is the hash of this current block, okay. If you edit or change anything, the hash changes. What is the hash? What is previous hash? These are all new terms apart from the data, which is obvious, is what you are storing. The hash is basically a digital fingerprint, okay. It's just like basically a way for you to find this information. Just like your Google Drive, they can use a SQL or whatever means of data base they use to store their information. This enables them to, anytime you want your data, you can easily find them fast and easy. A hash enables you to find a particular block and query it, or check anything you want to check inside that particular block. That is one of the functions of a hash, okay. The previous hash is simply a hash that has already been created and has been used to link with the current block, Okay, so it's basically the chain. The hash is the chain, and it's also the fingerprint, which is always unique. You know, fingerprint is always unique. So it is the chain and also the fingerprint of the blockchain. Okay, so new hashes are created every time a new block is completed. Okay, a new hash is created. The hash is not created before. It's only created after it has been completed. So when it is completed, a new hash is created and is used to link to the next one, like that, and it goes on. So that's basically how it is. If any data comes in again, the hash can never be the same if the data is, because basically if you store a data and it creates a hash and you add in a new data, what that means is that this fingerprint is now going to open the one that you created before. It's not going to create a kind of data. uh it's not going to, save, because that's not how it works. Basically, you can't edit the content of it, so it's going to do what? Updates the hash. Okay, so the hash cannot be the same after information has been added. That's basically one thing you have to know. So once a new block is created, inside the hashes are calculated, and changing something in the block will cause the hash to change. So which leads to the fact where I said that it is impossible to change things on the blockchain. Okay, let's go into looking at that further. So now let's say, for example, you have this block. The first block is known as the genesis block. We will come into looking at that in this video. So first of all, you have this first block and you have this next block. Now if you change anything on this block, remember what is linking this block here with this one is the previous hash. So changing anything, remember, it changes the fingerprint, it changes the hash, so it makes every other block that come after it invalid, and that is what makes it very, very difficult to do. Okay, because imagine you change something here and there are 10 million blocks ahead, or 10,000 blocks ahead. So it will be a very, very, very tedious process, because you have to be changing it through the end of the block. Okay, and with modern computers that can happen, but would prove how the blockchain ensures that this doesn't happen with modern computers or whatever. So once a new block is being created inside the blockchain, its hashes is calculated. Changing something in the block will cause the hash to change. So this tells us that the hashes is very useful when you get to detect a block. Okay, if each fingerprint or hashes, as I said, the fingerprint is also known as the hash. So if each fingerprint or hash changes, is no longer the same block. The block is another block entirely. Okay, if anything changes in it. Okay, and also the third element inside the block is the hash of the previous block, which makes it create what? The link. So if you want to go and change it on anyone, you have to make sure you ensure that the next block that is before it, the data that is there, you've already made sure that you've corrected whatever you want to do, and you've corrected for the next block the date, like that, which is a difficult process. Okay, so now let's go into further understanding of this. So now, as I said earlier, the genesis block is the first block, and it doesn't have any previous hash. That is why it is known as the genesis block. It is the first block that is being created, and it's, despite the fact it is a genesis block, it still has a hash. Remember, the hash is not talking anything about the previous, or it's not created because of the previous. It's created because of the data stored into it. Okay, so when data is added into a block, it creates this hash. Okay, it creates this hash, which enables whatever content or data that is in it to be secured. Okay, now the added security comes in when that previous hash is now used to, added here and used to create another block. So now when this new block comes in here with its own hash, it takes note of the previous hash. It can only come in under this thing when they have this previous. This is not the previous hash of this. Okay, for this third block, this is not you can't use the previous hash of this here, because it is not, because there's a data here which you have to reference it first. Okay, so I'm going to use fingerprints more often so you can get to understand. So for this to be linked, okay, you must take reference of the previous fingerprint. You need to unlock this one. You need to unlock this to get its data. Okay, so this previous hash here is the information of the previous hash. this hash here is the information that this other block has created, the fingerprint that this other one has created for the things that are stored on this. Okay, so it must be referenced very very well before the whole essence of the blockchain can work. So that is how it works. So now the next block is created, and the next block is created taking note of what the previous hash. You can't come without taking note of that, except you are a genesis block. Okay, and you can't have two genesis block in one blockchain. Okay, so that's basically it. Okay, so if this blockchain has this information of the previous hash, it now it adds its own data in its own block and now creates its own hash. This hash will now go into the next block, that is how it keeps going. Now changing anything here will require changing. Let's say you want to change any data here. If you try to change any data here, this hash will change. It must change because now a new fingerprint must be created for what? For this block. Okay, that is what happens when you add a new data. No matter how you think it is insignificant, even if it is a full stop you add as a data, whatever, it changes everything. Just like in your Word document, if you go and add a full stop or whatever, it's going to count it as a character. Okay, no matter how small it is still noted as a character. Okay, so you can basically see that. So now let's say that someone wants to temper. You can see that tempering on the second block changes the hash, which changes the fingerprint, which makes the third block and the following block to be invalid. Anything that comes in after changing this second one makes every other thing in front of it to be invalid. Okay, so it is very hard for you to change information that are in these blocks. Okay, you can't really do that. Okay, and now the blockchain uses mechanisms, uses a kind of mechanism known as a consensus mechanism, which is a way which these things work. Okay, it uses a consensus mechanism, a way which these things work, which members, me and you, we agree on things that are there, because since we are the one responsible for writing on the blockchain, we are the ones that are responsible for telling what is also right for the blockchain. We are telling, okay, yes, this guy is correct, this thing is correct, add it, or don't add it, or reject it. So that is basically what is known as a consensus. A consensus, from the word, it's just basically an English word. Consensus means the way of agreement. Okay, the way in which people or groups of people come into agreement. Okay, so the blockchain is a distributed ledger remember, it's a distributed ledger. So basically information recorded in it is a me and you decision. It's a me and you decision. So users of the blockchain, they agree on what is added and what is not original, or what is not supposed to. Let's say someone is trying to create a fake block or edit something, we can see, okay, yes, this is not valid. Instead, what do? We go to the block that we've been working on before, that we know this one is valid, and work on that. And as time goes on, that block he tried to create is going to expire. Okay, now this process, this consensus mechanism, they exist in different ways. There are different kinds of consensus mechanism. There are different ways in which we can agree on this. Okay, there's also the popular one is the one of the Bitcoin one, which is known as the proof of work. We'll come into that. Is a way in which the Bitcoin members of the Bitcoin blockchain, they verify transaction. The proof of work enables that no matter the fast kind of computer you use, you won't it's very impossible for you to try and change data or information that is written on the blockchain. Okay, on the Bitcoin blockchain. So now let's go into the types of blockchain, so we can basically understand what is all about before we head on to other things. So there are public blockchain, there are private blockchains, there are private, there are hybrid blockchains, there are consortium blockchains. Okay, all these are different types of blockchain, and we'll get to know their meanings each. So first of all is the public blockchain, the open blockchain, the one that is open. Okay, so first of all, this the feature of this blockchain. This kind of blockchain needs no permission from anyone to come in. Everyone has access to it. It has an open network. Examples of this kind of blockchain includes Bitcoin, Ethereum, Litecoin blockchain, EOS blockchain. So these are permissionless, meaning they don't require any permission for me to add information, for you to add information, for we basically are the one running it. We basically allow, or give rights to things that should be there and things should, it's open source. Basically it's open source, meaning it's open to the public to do. Okay, we'll come into further explanation of that. Then we also have a consensus algorithm, which is algorithm, which is how the blockchain, come into agreement. Remember, they have to be a way of agreement. So we have the proof of work, the proof of stake. So basically, proof of work verifies through the transaction, the miners or the people on the blockchain. Let me use those words so we don't get confused. So basically, the users on the blockchain, they come together and they try to find a solution of a hash, because the hash is difficult to create because of the design of this, of the way the blockchain works. Okay, it is made to be difficult so that for one person to create it, it's not something that can be easily done by computers anyhow, and to it would be useless. The whole essence of the blockchain would be useless if it is something that can be done by computers automatically, and fake blocks be created. So that would be very bad for the blockchain. But the proof of work algorithm ensures that, and the proof of stake also ensures that by people having to stake some quantity of uh, let's say tokens, or tokens of the blockchain, to enable facilitate the agreement on what should come in and what should not come in. Remember, you are hearing transaction most on the blockchain doesn't mean that it can be used for other purposes. The reason we are doing that is because the main use of which we are seeing how blockchain is used today in our society is to to facilitate in remittancy. Okay, so that's why you are hearing transaction quite often. So this type of blockchain, anyone can access public blockchain, as long as you have internet. And you know in such blockchain, verification of transaction can be done through a consensus algorithm, such as proof of work or proof of stake. So example, of course, as I said earlier, is Bitcoin, Ethereum, and EOS blockchain. There are other ones. These are just few ones to mention. So we have the next type of blockchain, which is known as the private blockchain. The private blockchain can be defined as a permissioned blockchain. Okay, now this is quite the opposite of the public blockchain. Okay, now in this case, this one needs permission. Okay, it needs permission to be able to access its environment. It is a closed network. It is thereby centralized. It is not as decentralized as the public blockchain. Okay, it is centralized. It is controlled under it is controlled by a single body. Okay, so it is under a single entity. That's one thing you need to know. So they basically, you might be, as I said, closed network. Basically, you might be asking, um, what's the difference between the private and the public blockchain? Okay, it is just the way it is assessed. The private is permissioned, meaning that anything that we have to write there, we are not the owners, we are not the one responsible for putting data there. So we have to take permission from the owners, okay, of that blockchain to add information to it. And we have to also it is also controlled by a single entity, so they are the ones responsible for adding those information. So we have examples of such, like the hyperledger fabric. Okay, so we are going to get to understand this in the course of our lessons. See, so basically there have been some arguments from people, they, because of the whole essence of the blockchain technology, people have argument that this is basically not a blockchain, it is just something that looks like it. Okay, but still there's space for it here, so we have to add it, private blockchain. So the use cases is used in supply chain management, asset ownership, and internal voting. Okay, within a single entity or a single organization, they can use it for voting. Okay, they can use it for proving asset ownership. Okay, you can use it for supply chain management. Okay, that's basically what it's about. So now we have another type of blockchain, which is known as the hybrid blockchain. So now sometimes organizations or entities will want the best of both worlds. They want the benefits of both private and public blockchain, but they want it to be confidential. Okay, so they, in this case, they creates this type of blockchain that is known as an hybrid blockchain, which combines the features of the private and the public blockchain together. Okay, so a type of blockchain that does this is known as a hybrid blockchain. So it lets organizations set up a private permission-based system alongside a public permissionless system. Remember, these are both the properties of a private and a public blockchain, allowing them to control who can access the data stored. Okay, now the data is now open, but they can, as it says, they can control who can see this data. Okay, who can control this data. Okay, but it is the data will be open up publicly. That's the main thing. But who can do it, who can do these changes? Okay, that's, there's control in this case. Okay, it is still centralized, as you can see. So typically transaction and records in hybrid blockchain are not made okay, typical transaction and records made in hybrid not made, but they can be verified such by following through a smart contract. So since it is public, the only way you can view it is using a smart contract. Okay, because of what? Confidential information. So it is open, but now for you to see it, you need a permission from what? The entity that is, the owner of this blockchain. Okay, so that is what basically hybrid blockchain helps us do. So confidential information is kept inside the network, but it is still verifiable by anyone. Anyone can go and verify, as long as you can see the information yourself. That means you have the permission to see the information. Anyone can verify. Okay, that has the access. Okay, so even though it is a private entity may own a blockchain, it cannot alter the transaction, it cannot alter things there, because what? It is verifiable. Okay, that's one of it. So let's look at its use case, where it is being used. It is used in real estate, it is used in health sector. So where you can see here that blockchains are used in vast ways apart from transactions. Okay, so now another type of blockchain is the consortium or the federated blockchain. Okay, this type of blockchain is controlled by a set or organization or nodes instead of a centralized node or a decentralized network. You see, okay, so a consortium blockchain comes with a pre-selected node. In a consortium blockchain, decisions are being controlled by users, and this is also referred to as a decentralized autonomous organization. Okay, so now what's the difference between what's basically the difference between the two? What's the difference between these two types of blockchain? Yeah, so because I'm probably guessing you are already wondering now, what's the difference between the consortium and the federated blockchain, by the way, because I mean, to me it sounds the same, right? Yes, it sounds okay. Now this type of blockchain is similar to the hybrid blockchain. If you're asking what's the difference between hybrid and consortium blockchain, okay, they are very very similar, but it's different is that multiple organization members collaborate on a decentralized network. Meanwhile, in a hybrid blockchain, in that case, what? It is public, okay, only to those that can view it. But in this case, it is in the case of consortium or federated blockchain, multiple organizational members collaborate on a decentralized network. They collaborate there to verify information, that comes into uh that blockchain. So consortium blockchains are related to enterprise use. Okay, they are basically used in enterprise use, where a group of organizations collaborating to leverage the blockchain to enhance their businesses. uh, 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 they make use of it. Okay, so of course it's used the public and private blockchain properties. It involves multiple organization. Okay, it involves multiple organization. Okay, not just one. So nevertheless, this sort of blockchain may allow certain participants to access or adopt a hybrid access method. As an example, the basic hash, its application interface, and all those kind of stuff. So, and also it's also can be hospitable for general public. Okay, so it can also be made for general public, which is why it combines the two properties of the properties from the public and the private blockchain So therefore, external entities can use the API to perform a particular number of inquiries and acquire certain information based with the blockchain status. Okay, so examples of consortium blockchain could be you'd have the quorum, we have the coda. Okay, but if you are coming into the blockchain space, depending on what you are coming in, if you are coming in for the cryptocurrency space, what you'll be mostly interested in is the public and the private blockchain. Okay, that's going to be basically more of your concern. Okay, then little of the hybrid blockchain. Okay, because that's mostly where most cryptocurrencies revolve around. So you have to understand them in detail of how they work. So the use case of this is used in banking and payment, food and medicine applications. So now let's go into looking at different places where blockchain technology can be applied. Okay, it can be used in remittance, of course, very very well. It's used in remittance. What is remittance? Okay, all about money sending and receiving. Okay, it can be used to record those kind of information in a what? A distributed ledger technology. Now it can be used in supply chain management. You can see the types of blockchain that support that. You can be used in healthcare. You can see the types of blockchain. It can be used in charity, to track basically information regarding how money is being spent for charities or all those kind of things. It can be used for decentralized finance. So what your bank can do can also be done on the blockchain. Lending, giving out loans. I'm sure you've heard of. I'm pretty sure you must have come across some of these things, or maybe you have not, but you would soon come across them as you go into this space of blockchain. So that's basically one of it. We also have decentralized applications. So the blockchain allows the creation of decentralized application. That means applications that are not controlled by one entity, they are controlled by groups of people. Okay, that's one of the blockchain allows building of games on it. It allows governance. It allows governance in the sense that you can use the blockchain to ensure correct voting count, because you can't change. And what makes our electoral bodies that are the traditional ones we have is that they can go in and change in that, since they are using traditional ways, either handwritten or sometimes they are using computer based this thing, which can be edited at any point in time. So the blockchain didn't just come out, let's say uh, to solve just transaction problems. As I said, you can see a list of things it does here, which is quite numerous. Okay, the blockchain IDFS came in around 1991, where some group of people came in to create a system where the people can store information and it is time stamped, which is one of the feature of the blockchain. Information also carry timestamps. They also carry timestamps and dates, okay, of transaction or things that go on within them. So the blockchain helped that. Okay, so it was basically not really used throughout those years till around 2008 2009, when Satoshi Nakamoto considered this and brought out the first implementation of the Bitcoin, of the blockchain technology on the Bitcoin blockchain. Okay, so that's basically a quick history on the history of blockchain, so you can get to uh, familiarize yourself with it. Then it can also be used in identity management, because remember, everything is unique, everything has its own unique fingerprint. It can be very very effective for identity management. Okay, you get to understand how this works in your journey in this space. Okay, now if you watch out for our subsequent videos, you see a lot of things we've been doing that explains more of blockchain as time goes on. Then we also have, can be used in Internet of Things. Basically, what that means, it can be used in various ways on the internet. So in case you are having, you are hearing of Internet of Things for the first time, IoT for the first time, it's not really a big word. It's simply the interconnection uh, uh, of computer devices with the help of the internet. Okay, I believe you know what the internet is, in everyday, which is embedded in everyday things that enables them to send and receive data. So when computers connect and they are able to send and receive data, that's basically Internet of Things. Okay, so the blockchain allows what we to connect and send and receive data send and receive transaction, which is what facilitating in Internet of Things. So that's basically what it means. So it's basically a network of physical objects. So now blockchain use cases in voting. Blockchain can be used in voting. Election function, the backbone of democracy. Okay, so if elections are to be done, which is to prove the democracy of the system, so the blockchain can be used, and we'll see how that can be done. So the convenience of digital voting is combined with the immutability of the blockchain. What is the immutability of the blockchain? The inability of it to change data or add or subtract without, without causing trouble. Okay, so immutability, of course, it's one of the features of the blockchain. So you can't just do anything without creating an alarm on the blockchain. Okay, which of course it won't end up getting uh, agreed on. So it eliminates the issues of like double voting. You can't send in double votes. Election rigging, vote altering, you can't even do that. The blockchain can't allow that. And vote deleting, you can't even delete someone's vote that to make you the winner, because the blockchain has ensured the security of that. And I often resolve once we apply the blockchain. So this may reduce the value of on paying. Okay, so basically if that is used, it ensures that our democratic system is kept on check, okay, without cheats and without cheats. So that's basically it on that. Okay, now let's look at another blockchain use case, which is smart contract. Okay, um blockchain based smart contracts are digital contracts that run on computerized transaction protocol monitored by number of nodes. That's another new theme. What are nodes? Okay, nodes are basically, remember, the blockchain needs users to verify transaction, to verify data that comes in on it. Okay, so what are nodes, you might be asking? Well, ask not for that. Nodes are basically me and you. Okay, we are the nodes. Okay, we are responsible for adding this thing. So we are known as nodes. We are not known as our names. We are not known as human being or whatever. We are known as nodes. Okay, so whenever I pick up my computer and I use it to verify transaction, use it to create data for the blockchain, I am known as a node. Okay, because what, I am a central point, okay, that of or parts of that blockchain. Okay, so we are the nodes are very very important in any blockchain to to ensure that transactions are being verified. Okay, so what are smart contracts, which is what we are looking at. So okay, so this blockchain based smart contracts are digital contracts. They are basically the traditional contract that but they are digital, that run on computerized transaction protocol monitored by a number of nodes connected to a blockchain network. So since blockchain contracts work on decentralized system between all permitted parties, that is between what, all the nodes, it can self-execute and self-maintain, thereby eliminating the need for intermediaries. Okay, so when with the use of a smart contract, there's no need for you to go and contact a lawyer, and some people, they want to send in money, they want to buy something, they put a PND, a post no debit. If you understand what that means, that means basically that money that you send to that person, the person can't use it until he executes or he gives you what you wanted. So now the blockchain, instead of having to go and do all those paperwork, having to go through all those stress, okay, the blockchain does that easily with the help of a smart contract. Okay, so which ensures that if this party doesn't fulfill this condition, this is not released to him. Okay, just like if you can set orders, pending orders on the market. If the price of a particular commodity doesn't, or a particular coin doesn't get to where you want it to go, you don't want to buy it there, or you don't want to sell it there. So that's basically what smart contract can help us do. You can see how useful that is on the blockchain. So according to Nick Szabo, the American computer scientist who invented smart contracts, it is a computerized transaction protocol that executes the terms of a contract. So first of all, the smart contract, you have to first of all tell it the terms of the contract. First of all, just like the lawyer, you have to tell, okay, this is what we want to do. I want to send him this money, so this is the contract. He has agreed that if if I send the money to him, he's going to give me this. So once he does that, allow the money to go to him. So when you hear contract, you think of a signed piece of paper that a legal agreement or this. But for the smart contract, it's an arrangement between two parties or more that are transparent and are very traceable, that are secure and irreversible because of what they're using the blockchain. This is why several companies are adopting the system to eliminate third parties. Example, financial sectors. With smart contract, one can sell assets without the need of a third party. You can do that without the need of a third party being involved, okay, which is a very very secure means. So instead of you to have third parties to come into lands or all those kind of things, simply have a contract that is arranged smartly on the blockchain, which allows you to uh, make use of um, the beauty of the internet and ensure that your transaction or whatever it is you are doing, you get you get the result you need. So now we got another thing here, which is terms used in blockchain. So we are going to explain some of those terms we've mentioned earlier, which might be troubling to you. Okay, remember, we are trying to make this as easy as possible, the word blockchain and cryptocurrency, to be easy as possible to you that is just coming in, or probably you know of the blockchain before you would want to learn more. So this is basically this playlist will basically help you to understand that. So the hash, now first of all, the hash, the groups of blocks which the blockchain miners are charged with, must be validated by the system. To do this, the miners must find a password or a digital fingerprint. Remember, that is what the hash stands for. They must find a digital fingerprint that, or a digital fingerprint that's a hash that identifies them. The password is not called what? A hash. Yes, it is unique, unrepeatable. That's the main essence of fingerprints being used there as a word. So because very very unique, unrepeatable, and cannot be modified. So what miners are charged, we'll get to know what a miner is, are charged with validating that. They have to find which password is correct. Just like you pick up someone's phone and okay, for example, we have 7 billion people in the world now. So you just saw someone's phone on the floor, and you know one thing, that the person is alive, and you want to unlock this phone with the person's fingerprints. So now you have to search through the whole world to find out whose fingerprint can unlock that phone. And in the process, you are definitely going to find it, okay, as long as you've known that, okay, the person is still active. Okay, so you can find that and find the person, and that phone can only be unlocked by that person's fingerprint. So that's what basically the blockchain does. So you can see how tedious it is for you to go around 7 billion people in the world, okay, to get that. That is how difficult the blockchain makes it. So for miner, that's why it's not a one person's responsibility. Miners come in together, they search this thing using fast computing power to search this thing. The first person that sees it now does what? It broadcasts the information. Hey, I've seen the solution to this block, I've seen the solution to this thing, at least the fingerprint that can unlock it. Now let's go into looking for the next one. That what does that do now? The chains of block, they keep on being added, like that, like that, like that. So that's basically how that works. So a miner is a node in the network that collects transactions and organizes them into blocks. That's what a miner basically does. Okay, so the miners are the ones that validate this system. So they are the ones that collect this transaction, this data that comes in. So when data comes in, they carry it, put inside a block, put inside a block, put inside a block. Once the block is filled with data, what do? They look for that. They work for it. They work for it. They work to see what can make, what can unlock this transaction, what can be a digital fingerprint for this group of blocks, or this group of transaction inside this block, or this group of data inside this block. So nodes are computers. Okay, nodes are computers that form part of the blockchain. So basically I call it me and you, because the computer is very very dumb. The computer knows nothing. The computer is you. Your computer can't work on its own. It can't just sit down and perform operation on its own. Okay, you have to tell it, this is what you have to do when this happens, this is do this. So basically we are the nodes, and then the computers act as doing that for us, because we can't stay there real time to do that. So they are charged with storing and distributing the data in real time. Okay, the updated copies of the transaction that are carried out. So once a transaction is mine, the note will now receive it. I've received my own copy, send to the next person, send to like that. That's what responsibility of a node is to the blockchain. So now we have other terms. We have proof of work, which I already explained earlier. Proof of work is a traditional method or a consensus mechanism that awards miners for their efforts. Okay, so we have the proof of stake allows a person to validate or mine a cryptocurrency based on the number of coins he or she owns. So because of the coins, they are going to be able to validate transactions using that. Okay, then we also have mining is a process of verifying new transaction to the blockchain or on the blockchain. So when someone says I am mining coin, it means the person is simply saying I am responsible for verifying new transaction on this blockchain. I see a lot of people mining things that are not even a blockchain. They are not even they just mine figures or number that are that's not how mining works. That's one way I came into the crypto space, which is really really rare. So people believe that they can just mine things anyhow. You have to mine things that already have a blockchain. You have to mine things that you mining, basically the whole essence is to verify new transaction. So if you are mining, if you are opening your app and clicking on a button to do something, basically what you're just doing is you are generating ad revenue for whatever that app is. Okay, that's what you are doing, and it's a long kind of term scam that one of the things that happen in this space, so you have to be aware of. So in the course of this playlist, you are going to learn some scams available in the crypto space. You are going to see all these things and you know how to prevent yourself. This basically, from this playlist, you are going to be almost ready, because you have to put in your own part or your own work. You have to do more research from your own side. You are going to be able to understand basically how the blockchain and how the cryptocurrency space works. Is going to help you really really a lot, and I can bet on that. So just stay on and watch the next videos in this playlist. um, Thank you for watching. This is the size of the introduction to blockchain. Let's get to the next video.